Good morning, everyone, and welcome to the Fiber Broadband Association's Fiber for Breakfast. We're now in our 14th episode of 2022. But before I kick off, I'd like to thank our sponsors of Fiber for Breakfast, including our gold sponsors, CHR Solutions, Millennium, and Plume, and our silver sponsor, Graybar. Last week, the FCC released its 5-year strategic plan, and the Commission's #1 goal is to pursue 100% broadband policy. The FCC highlights that broadband is essential for Americans to work remotely, learn remotely, and receive healthcare and engage in commerce. To this end, the FCC will pursue policies to help bring affordable, reliable, and high-speed broadband to 100% of the country. The Commission's #2 goal is to promote diversity, equity, inclusion, and accessibility through digital technologies and next-generation networks. Its other goals include empowering consumers, enhancing public safety and national security, advancing new technologies such as 5G, and lastly, to effectively manage its resources. As we head into spring, I'm very excited about our next regional Fiber Connect event at the Omni in Providence, Rhode Island on Tuesday, April 19th. We've invited Governor Dan McKee and Kevin Gallagher from the U.S. Department of Commerce to speak. We'll also hear from Daniela Fairchild, the Rhode Island Commerce, who is the state broadband director, and we'll hear from State Rep Deb Ruggiero, who is an outspoken advocate for fiber. We have a great lineup of speakers, and we expect to have a broad audience of community leaders from across New England. So you're not going to want to miss this. After Rhode Island, we'll be heading into Nashville from June 12th to 15th for Fiber Connect 2022. Our annual conference is shaping up to be the top event in the industry this year, with over 200 speakers and 170 sessions. It's going to be absolutely amazing. So if you haven't registered during the early bird registration, that ends on April 15th. With that early bird, you also get free admission into our pre-conference workshops, which we have 5 this year. After Nashville, we'll be at Copper Mountain Resort in Colorado in August 23rd, and then in Columbus, Ohio on November 3rd. So we hope to see you at one of these events. As we think about quantum advances in technology, I'm very excited about today's Fiber for Breakfast session. Today, we're going to be discussing the Terabit Edge. But before I formally introduce today's guests, I'd like to introduce Trish Ehlers from our team, who's going to walk us through some housekeeping items.
Thanks, Gary, and good morning to everyone who's joined us today. Before I go over a few logistical items, I'd once again like to thank our Fiber for Breakfast sponsors, gold sponsor CHR Solutions, Millennium and Plume, and silver sponsor Graybar. Now, if you'd all keep in mind that everyone is in listen mode only, to ask a question, you can just type it into the question box located within your control panel on the right side of your screen. We'll host a Q&A session with our panelists at the end of today's session. This presentation is being recorded and will be available to members only on FBA's website within 24 hours. You can find the recording in the Events tab under the Fiber for Breakfast drop-down option. At the conclusion of the presentation, you'll be prompted to complete a brief feedback survey. Please do take a minute to do that. We really appreciate your input. I'll pass it back to Gary now to introduce our panelists and get us started. Gary?
Thanks, Trish, and good morning. I'm Gary Bolton, the President and CEO of the Fiber Broadband Association. Last week at Fiber for Breakfast, we spoke with Brian Darr from Ookla on crowdsourced network performance data insights into customer experience and broadband funding opportunities. It's amazing that Ookla has run over 40 billion speed tests worldwide. I was encouraged to hear that 80%, that's 80% of all wireless traffic goes over the fixed network. And Ookla can now measure the significant latency performance improvements when that traffic goes across a fiber network. Very cool. So this morning, we have the pleasure to speak with my former colleague from over 15 years ago, Stephen Alexander, the CTO for Ciena on the Terabit Edge. Continued advancements in WDM and coherent optical systems have allowed over 100x improvement in the amount of information that can be carried across an optical fiber. We're now seeing 30, 50, and even 60 terabytes per second routinely designed into long-haul networks. Steve Alexander is Ciena's Senior Vice President and Chief Technology Officer. And from 1982 until joining Ciena in 1994, he was Assistant Leader in the Optical Communications Technology Group at MIT Lincoln Laboratories. He is an IEEE Fellow and recipient of the IEEE Communications Society Industrial Innovation Award. Steve is a member of the Board of Directors at ATIS, and he has served as a member of the FCC Technology Advisory Council and is chairman of Long Range Planning Committee for OFC. Steven is an electrical engineer graduate from Georgia Tech, and he has been granted 23 patents and authored a text on optical communication receiver design, as well as numerous conference presentations and journals. Welcome, Steve. And for our audience, please type your questions as you go, and we'll hit them at the Q&A at the end of the session. So with that, I'll turn things over to Steve.
Thanks, Gary. It's great to be here with you again. You guys go to some cool places. I'm going to hang out with you more often. I love the title of the upcoming event in Nashville, right? Unlimited bandwidth and just super possibilities. So what I want to do today is talk to people about what we've termed the Terabit Edge, because in the past, if we talked about terabits, kind of people immediately kind of get scared and say, oh my God, that must be hard and huge and power consuming and just very, very difficult. But I think there's some real motivations now for why you have to explore kind of different architectures out at the edge of the network. So let's go to the next slide. What's happened during COVID is, I think, some kind of fundamental changes in how people look at connectivity, and it's just changed what our expectations are. When we were sitting at home, and by the way, I am at home, I'm in my house in Annapolis here. You thought, well, look, I'm going to stream, I'm going to do some browsing, I'll chat, I'll do some kind of typical online experiences and such. But you fast forward to where we are now, and I look at what's possible in the future, and I see what, for example, my oldest son just did. He's engaged, he just bought his first house during the pandemic. We always used to say real estate, it's location, location, location. And a lot of that's still true. But I'm going to tell you now, when they were house hunting, he and his fiance, it was, location, location, network, right? Because they both can work from home, not full time, but he can do it more than she can. She's a film editor, lots of information flowing back and forth, even 4K, 8K materials she works on. That requires connectivity. So when they were looking for a house, yeah, it was all about location, but the second question was, is that location connected, and is it connected adequately? And I think that transition in our thinking about what we want from our residents is going to drive a lot of just change in how we look at what we expect from the network. So let's go on to the next slide, please. What you'll see with optical technology, and you touched on this a little bit earlier, is there has been tremendous advances over the last couple of decades from just raw capacity. And one thing I think Ciena is justifiably proud of, if you look in that top left chart, that higher capacity, we're the company that first commercialized dense wavelength division multiplexing back in the middle 90s, and the first to commercialize coherent detection in these systems around 2010, right? And coherent detection is the use of a laser to measure a laser. You got a laser in the receiver, it measures the incoming light from the other laser. You get lots of capacity enhancements when you can do that. We've also been able to drive costs down very dramatically in terms of what's it cost per bit to send information. And this has been because we've adopted the WDM technologies, and we've been able to adopt the coherent detection technologies. And that's also resulted in smaller size. And I'm going to double click on that in a minute, because I think the size piece of this is as impressive as anything else that's been accomplished. And so the basic optical technologies has really become now pervasive across a whole host of applications. We've used it for submarine systems for a long, long time, tens of thousands of kilometers. It's, 99.9% of all the traffic that goes between, continents is on submarine cables now. It's in what we call multi-haul environments, where you're doing, whether you're on a metro or a long-haul system, these are all fiber-based. Data center interconnect, that's the DCI space, tens to thousands of kilometers, but massive capacities between these giant data centers that are being built. And now there's lots of opportunity to take these same kinds of improvements from a capacity, from a cost, and from a size perspective, and drive them further out to the edge of the network. Fiber in the access, fiber deep, the modernization of what the old coax plants look like, what 5G towers are connected. The vast majority of those are going to require fiber connectivity. Even inside the data center, right, there's lots of potential use for these kinds of technologies to continue to improve the connectivity and just the basic performance of the network infrastructure. But again, let me double click on the smaller size one, because I think that's really interesting. So if you go to the next slide, and Gary, I think you'll appreciate this as much as anybody, because you remember what it was like 15, 20, 25 years ago. In 1995, when Ciena came to market, we were the first to commercialize what's called dense wavelength division multiplexing. So lots of colors of light on a single fiber, different information on each color, you get a lot of capacity multiplication. But the size of it, the physical size, okay, 16 wavelengths of what was then 2.5 gigabits, that occupied about one telco bay, right? So one full-size bay, 6, 7 feet high, 23 inches wide, 12, 18 inches deep, right? So I mean, it's a good size, piece of equipment sitting there. If I was going to do 400 gig, I would need 10 of those bays. So that's kind of the mental picture you have to hold in your head, is 10 of these telecom bays sitting there to carry 400 gigabits. Now, fast forward to now 2022. There's a technology out there that we've helped develop along with the rest of the industry called the 400ZR, and it's a way to produce capacity that literally fits in the palm of your hand. And I've got one of these things. Okay, that's a 400 gig transceiver thing. Right, so this is 10 of those original bays worth of equipment, and it now sits right here in my hand, right? And so you think, okay, well, a couple of these is 800 gig, 3 of these is 1.2 terabits. I mean, that's not physically large all of a sudden. And in fact, if I can accomplish one thing today with this webinar, I want to get it in people's minds that when people talk about terabits, it's not massive amounts of equipment, massive power consumption, and massive cost. You can do 10 terabits of aggregation in a rack unit or two. Again, I can put 400 gig in the palm of your hand, and once I can do that, I can put it almost anywhere in the network that I need it, right? So it's really changed the game in terms of what we can do with fiber, and really where can fiber go and what can fiber deliver to us, right? So that's mission one for me, is to say, when you think about a terabit, it's not a huge amount of volume, of cost, of space anymore, right? Think 400 gig in the palm of your hand. So let's go to the next slide. The other one that I wanted to bring up is just the continued advancement and actually acceleration about what goes on out at the edge of the network. And so when I say edge here, what I did is I took information from the Ethernet Alliance. So most people will say Ethernet, well, that's a local area networking speed. It's something that maybe I have it in my house. It may connect from my computer over to my printer. Maybe I have a little local area network in my school or my office building, right? That's a LAN technology. Well, if you look at the history of Ethernet, right, it'll go all the way back to the 1980s when it was first created up until today, you'll see on this chart there were 6 rates were created in about 35 years. That's how long it took us to get the first 6 rates, okay? Now, what I've also done on here is across the top, I've put a listing of the silicon node technology that was available at the time, because the silicon, the density of the silicon, number of transistors you can get, number of gates you can build, drives a lot of what you can do on the networking side. And as silicon has continued to advance, especially now that we're down into kind of single digit nanometers, all of a sudden we can do so much more, right? And in fact, in just the last 3 years, we've got 6 rates that have been created, right? A lot of these were to support the rollout of things like 5G, 25 gigabits, for example, PON services, 10 gigabits, 25 gigabits, new broadband services for data centers, 400 gigabits back to the 400ZR. So let's look into the future, right? Today, the highest rate that Ciena ships on a routine basis is 800 gig on an individual wavelength, right? So what's the future going to bring us? Well, 1.6 terabits is going to be there, 3.2 terabits. Silicon continues to advance. You can see your way to 6.4 terabits. So keep in mind, these are conceivably edge of network, local area networking speeds conceptually, right? This is Ethernet running at multiple terabits. So you have this kind of quandary saying, look, if I got LAN technologies that are doing terabits, why can't my WAN, my wide area network technology, do the same thing? And the message here is, well, it can, because in fact, there's this convergence between all those technologies now. So if you have something that's a gigabit in your house, you should be able to get it in and out of your house, in and out of your factory, in and out of your enterprise, because all these optical technologies now exist to support this. Okay. So let's go on to the next slide, because I know a couple of your webinars back, you had a great discussion on latency. And I think latency is one not well understood and actually very important parameter going out into the future. And in fact, I term it a little differently. I call it mean time to cloud, because what I want to do is not just talk about network latency. I want to bring in latency between everything. So from whatever smart device you have out at the edge of the network, whether it's your phone, your computer, your smart TV, your crypto mining machine, whatever it is that sits out at the edge of the network, in the cloud, you want some kind of cloud experience. I mean, what we have going on here basically is a cloud experience, right? There's an expectation around how quickly all that happens. And so what I've done on here is just put some parameters out here. Across the bottom on the x-axis, you have latency, microseconds up to seconds. You've got bandwidth on the left and the y-axis. 4 big groupings, control loops in the bottom left, AR, VR top left, video top right, Internet of Things in the bottom right. And I just picked a couple of places on here. Motion sickness, right? There's some good evidence out there that the most sensitive people to motion sickness, if you get interactions under 10 milliseconds, they never get sick. They can play games all day long. They can do AR, VR all day long, whatever you want. It's about a 10 millisecond location. There's also on there kind of the old FCC number around 25 megabits in terms of what broadband definitions were, just to kind of scope things in. Now, 10 milliseconds on fiber, that's a long way. That's 1,000 kilometers. But that's if all of it is in the network. If I come to you and say, no, the network only gets half, you know, there's a latency budget from all the devices, from all the protocol stacks you got to go up and down, the cloud's got to process what you're doing. I'm only going to give you half in the network. Oh, okay, well, now you better be 500 kilometers away. You say, well, no, I can only give you 10%, right? I got 90% for the equipment and the software and all the other stuff. The network only gets 10% of the latency. Boom, all of a sudden now the first cloud experience has to be 100 kilometers away, right? And so what's happening as we get all these additional kinds of capabilities, we move from just streaming video, and we get immersive video, we get to tactile internet, we get autonomous vehicles, and not necessarily autonomous cars I'm talking about here. I'm talking about autonomous forklifts in a warehouse, or autonomous, you know, assembly of a train in a train marshaling yard, right? Those kinds of events that are truly autonomous, that require, you know, connectivity, but also low latency. You've got robots on a factory floor, right? All those things require fairly tight control loops, fairly low latency. All that governs where your first cloud experience is going to be. And so you have this spectrum of requirements that sit there, and you say, okay, how does the network address this? Well, it needs to bring the cloud edge closer, right? So we've got this phenomenon going on of the cloud is just coming closer to us because we want it to be able to support all these advanced experiences. Let's go on to the next slide, because this is another, what I would call, digital divide that we're going to deal with now, right? We know how to light a fiber to, as you mentioned in the introduction, 30, 40, 50, 60 terabits per second. You take that fiber, you go out to the edge of the network, and all of a sudden we start arguing around, well, is this megabits or is it gigabits, right? And so the whole world, our online experience, the whole digital environment we're trying to create is moving from one where it's largely based on external consumption. That's that bottom right area, right? That's, yeah, 10, 100 milliseconds, kind of moderate bandwidth. Okay, I'm just consuming stuff. I'm looking at stuff. I'm being entertained. Okay. Now we're moving into a world where it's more immersive, but we want to get to a world where it's immersive and interactive. Well, that's going to require low latency and high bandwidth simultaneously. So where do we put the stop sign, right? Because that's going to in itself create another digital divide. We know we have technologies, core networks, 40, 50, 60 terabit. You want it easy, no problem. Edge of the network, 400 gig in the palm of your hand. Pretty interesting kind of capability. So, you know, where do we put that stop sign? Because that's going to set another digital divide of the who can experience it and who can't, based on what kind of applications and cloud-based, you know, experiences that you want. Okay. So the next slide, I think this is the last one that I've got. What this talks about is where people really want to get to, right? You want a common hardware platform, you know, as common as you can make it, and then personalized services, and you want a multi-cloud experience. Whether you're going to public clouds or private clouds, or you're going out to the grand internet, you know, you're running a business, you're probably buying services from 3, 4, 5, 10, 20 different cloud providers. right? You're getting your entertainment from different streaming services. You're going to educational services. You're going to healthcare services. You know, whatever you're doing, right? That you want that multi-cloud experience. Common hardware. So, you know, if you're doing enterprise, common hardware, put software on it that creates a big data experience for you, so you can see, you know, what are your customers doing? What do you need to do in your supply chain? You know, if you're a government and you're running smart city applications, if you're in retail, here's a box that's running, you know, same kind of hardware, but now you're doing point of sale. If you're in education, probably content distribution and delivery to the students, right? If you're in a mobility game, you're doing, you know, Evolved Packet Core, the 5G core, right? You want that kind of capability to say, here's the connection, here's the high capacity, program it up any way you want, and off you go. That's the environment that you really want to have out at the edge. And to enable this, that's why, you know, we're so interested in starting to introduce these same kind of technologies, the you know, XGS PON kinds of technologies, get the capacity up, start to shoot for these very high capacity capabilities that we know we can do in the core. Let's start bringing them out to the edge. Okay. So with that, I think that was the last slide I've got. I'll thank everybody and happy to take any questions that anybody has.
Steve, great stuff. I love the you know, 400 gig in the palm of your hand. That's awesome. Yeah, who would have ever imagined, right?
Oh no, it's you think about what's sitting inside this thing from a complexity point of view. It's remarkable, right?
You know, it kind of reminds me of you know, one of my favorite books was Michio Kaku's Future of Physics, and he says that we're the last generation that's going to die because you can, you know, there's all this technology coming, and it's kind of like, well, maybe I was born a generation too early, but this is great stuff. So, you know, when you think about work from home, isn't you know, fiber to the home now essentially the enterprise distributed network?
Yes, in fact, I think there's a case to be made that it's all the same essentially, right? Your environment has got to be done in a way that you have the same experience inside your house, walking out of your house, getting in your car, going to work, at work. You want that same experience, right? And so your point's an excellent one. You look at what happened to Ciena, right? Ciena before COVID, and you know, everybody had to go home for work. We had to probably manage our CIO, maybe 50 locations were the enterprise locations he had to deal with. COVID hits, everybody goes home. He's got 5,000, 6,000 locations you got to manage all of a sudden. And so the one thing that I find is people still think, well, there's an enterprise network and there's a residential network. Well, okay, I'm sitting at home running on a residential service. This is an enterprise application, right? So tell me, how are they different anymore, right? I want that same experience. I could be doing this at work. I could be doing this at home. I don't want them to be different. I want that kind of same seamless experience, and that requires a different way of thinking. So we like ideas around universal access. You know, you have a box at the edge of the network. It's fed by terabits, 400 gig, couple 400 gigs, 800 gigs, whatever's needed, and then kind of port by port, plug by plug. You know, PON, wireless, Ethernet, WDM, whatever you need, right? You do it that way as opposed to saying, okay, I've got to have a physically separate network, and then someplace way up in the core, I'm going to converge on that. That's old school thinking. That has to change to enable this new kind of work, you know, work for anyone from anywhere, learn anything from anywhere, right? You want that experience out at your house, you got to change the architecture.
Well, exactly. You know, I think about healthcare and you know, school and everything. It really is our enterprise applications. We have a ton of questions here. So let's see if we can get to as many of these as possible. So looking at edge data centers, how much space, power, and HVAC should I be looking for or budget for a new site? You know, you talked about low power and small space, but what about heat? What does that 4 gig module plug into? Is it something like a small bread box?
So these guys run 15, 16, 17 watts, depends upon the total switch that you have that goes there. The edge data center question is a really, really good one, because I don't want people to walk away from this saying the entire cloud experience sits at that edge, right? The way that the cloud will evolve is to say, you got an experience that you want. We'll just make it up and say it's an AR, VR enhanced educational environment. Only a piece of it the only piece of that entire set of workloads is going to require low latency close to you. There's other pieces that can be put almost anywhere in the cloud they need to be. The intelligence in the cloud has to evolve to the point where it can take your entire experience, break the workloads up and say, okay, this is the one that needs to be close to you for low latency. This is one that can be located over here for efficiency. Here's one that can be located very far away because you're just going to download it once, or you're going to stream differently, right? That's the level of intelligence you have to get to. That's where things become, fabrics that can, essentially dynamically adapt, can self-optimize, can work, for creating the experience that you want. I don't want people to walk away saying, I've got to take all the complexity of a hypergiant data center and just take a slice of it and stick it out at the edge. That's not really what we're talking about. We're saying pieces of your cloud experience that require low latency have to be close. Physics requires it. There's no way around that one. Others you can put elsewhere.
So this, I think you talked a little bit about this, but what's your definition of the edge? How close do we need to get?
Yeah. Well, so one of the reasons that I put that edge up there, so I like to talk about the edge in terms of mean time to cloud, because that's what governs your user experience, right? There's so many different edges out there. People will talk about the observable edge, the administrative edge, the near edge, the far edge, all that stuff. And we have a very hard time of getting agreement about what edge means. If I say, tell me what your mean time to cloud requirement is, I can tell you where the edge has to be, right? And so what you're going to find is there's a whole variety of requirements of where edge is. And there are some schools of thought, just if you want to go way out into the future, because we like that stuff, to say, look, I'm sitting at my house, sitting upstairs is a Mac Pro that's not doing anything right now. Why shouldn't that be part of an edge cloud environment that could be accessed for folks who are doing, distributed computing, right? That moves the edge basically right out to that machine. So I don't want to give you a definition in terms of a geography, because I really don't think it's the right way to do it. I think you have to go to what experience are you trying to get to, what's the mean time to cloud requirements that you have for that experience, and then I'm going to tell you what that requires the edge to be located at.
Hey, so Cable Labs has suggested that edge networks could support up to 1 to 2 terabits per second in the near term. Will mass production of electronics make that possible?
Well, let's see. I would tell you they're spot on. I mean, an edge network today, depending upon what you want to define the network to be. I mean, if I give you a fiber, I can light it today with, in our world, it would be a product called Wave Server that would let you put terabits over it, right? And we know people that do that today. If you have a big factory, a big manufacturing plant, a big campus environment, you want to put terabits to that location, a couple of fibers in the ground. In our world, it's called Wave Servers at either end, and off you go, got terabits. So sure, mass manufacturing of consistent common parts will drive costs down, right? And that's why, as optics got into data centers and the volumes just exploded, costs came down. That's why, having this with a common set of, requirements around what OIF put together will drive volumes up and will drive costs down. So absolutely, you have to be able to scale manufacturing to get the costs out.
So there's a follow-up question on, are there measurements for different vendors in terms of latency, since going through the network makes latency as viable as the equipment that you route it through?
Absolutely, and it's not I would say it's not really well done today, because there's such a variety of performance that you can obtain, right? There's people that talk about, well, unloaded latency, loaded latency, when I have a lot of congestion, right? What I can tell you absolutely is, if you want to solve the congestion at the edge, assuming you keep the buffers reasonable sizes and you use, recent modern electronics and good network design, you throw capacity at it, because packet networks work really, really well when they have a lot of capacity to use, right? And again, I'll go back to, 25 years ago, I would have been rolling in racks worth of equipment if you said I wanted hundreds of gigabits, and here we got 400 gig, right? So it's a different world. We have to think about it differently. When you put a fiber in the ground, think terabits. There may be all sorts of wonderful reasons that today we can only light it at gigabits and the rest, but understand what's sitting there has the potential to carry terabits. Let's not make any architectural decisions now that frustrate our ability to use that later.
Well, Steve, this has been fantastic. I always love hearing from you, and it's been great to catch up. But really appreciate the significant advancements that in optics that you and Ciena have contributed to the industry. So thank you guys for that. So again, thanks for joining us today. I look forward to getting back together next Wednesday. We'll be discussing the role of rural broadband for Ozark Go. This is with Steve Bandy, the GM of Ozark Go, and he's going to discuss their 5-year fiber construction within their electric co-op footprint. So you're not going to want to miss that. We'll see you next Wednesday. Thanks, everyone. Thanks, Steve.
See you.